Hello everyone, my name is Ritesh and our today's topic for discussion is friction car wars. Now, by the topic friction, you might know that what are we going to study about basically? It's friction and car wars. We'll be studying that later. It's some fun part. So, let us start with the friction. But what is friction? Friction is one kind of force that is exerted when two surfaces rub on each other or exerts the force on each other. So, first, basically, we are going to learn about what is force. So, force. A force is a push or pull upon an object resulting from the object's interaction with another object. So, here you can see in the images like a push or a pull that this person is pulling and this is applying a force to pull that particular object, and the other person is pushing that. So that is another type of force it is exerting on that blue box to move it from its place. And here we can see another example that two-person are pulling the rope or single rope. So a person is in a single direction, let's say positive x-axis, and this other person is pulling it in negative x-axis. And by if you know it, vector is a force is a vector quantity. So by vector, two vectors of same magnitude, if they are in opposite to each other, then they cancel each other and the rope will not move from its place, or any object on which these forces are exerted, it will not move. So it is slightly different, but we are going to require it in force object. So we will be studying about frictional force right now. So, frictional force refers to the force generated by two surfaces that contacts and slide against each other. And that is the basic, what we can say. This is the basic phenomenon by which uh, everything happens. Like if we are walking, our weight is on the ground, and that's why when we are sliding it, our leg is not moving backward. It might, but slightly, uh, but rather our body moves forward. So this is an most common example we can say of frictional force, like walking, and everything basically around us happens is by frictional force. Now, for example, I am holding this phone in my hand right now. So here there are frictional force between my this finger and this phone. That's why the phone is not falling off from my hand. But what if I just decrease this frictional force by not applying much pressure vertically on my on this phone? So if I release it, it will fall. Like if I don't apply the force much. Now we'll see an example. I am releasing it, so frictional force is falling off, and that's why the friction lowers down, and thus the phone falls, or gravity pulls it toward it. This is one of the common example, and the few factors affecting the frictional force are these forces are mainly affected by the surface texture and the amount of force implying them together. Yes. Now, what is the surface texture? Like how rough the surface is. The more rough surface, the more friction will be produced between those two objects, and the amount of force implying them together. So, which I just explained, the amount of force. I am holding this phone with with usual amount of force applying on both fingers. But if I decrease the force, the phone will fall off. This is the example of amount of force impelling on them. And now the texture. If we have some rough surface, then it will generate more force. I don't have example any right now. I may have this torch. So here you may see some lines over here. So this is nothing but it is used to generate some force or friction. So it's a rough surface, that's why it will generate more friction, and it will be easier to hold in my hand right now, or I just can hold it with two fingers, and with least amount of force. So this is why the friction and the mainly the texture of the surface is very important. Now, when the surface is in contact, move relative to each other, the friction between the two surfaces converts kinetic energy into the thermal energy. That is, it converts work into heat. And this property can have dramatic consequences, as illustrated by the use of friction created by rubbing the pieces of wood together to start the fire. Yes, you might have seen TV shows in which he uses wood, and by rubbing like this it generates fire. Or you might can demonstrate it right now. You just use your hands and rub it like this, so you may feel some heat on your hand. So it is nothing but these are, imagine these are two rough surfaces, and since these are slightly rough surfaces, that's why it will produce more friction. And we are rubbing it against each other, and if we just slightly rub it without using much vertical force on it, it will not generate much heat, but it will generate some amount of heat. And if we somehow increase the speed, it will increase the amount of heat produced. And if we increase the vertical force but doing there, then it will obviously generate more amount of heat. So these all other factors which are mainly responsible for generating heat using friction. And but friction is very important, as I just uh, in I just told you in starting of the lecture. So, and these properties are by default, that we cannot do anything about it. Its kinetic energy is converted into thermal energy. It's natural. Now, here we have an interesting experiment. So, materials required are shoebox, cardboard of good strength. It have to be a good strength. Then, chart paper, a bowl of any pulses. Then, two toy cars and Fevicol. You might have these at your home. So, let's see the procedure for it. Now, cut two long vertical stripes from the cardboard and place the chart paper on one side of strips. Put some Fevicol on one of the stripes and sprinkle the pulses all over it. Allow it to dry. So that what we are right now creating is, we are creating a rough path, so that the pulses over there, and it will create some roughness in our path. Then place one end of both of the cardboard stripes at the edge of the shoe box. Then place the two toy cars and gently push them on the two cardboard stripes. Make a note of which car reaches the ground first, along with all your other observations. So basically what we are going to create is, imagine this is a vertical shoe box, and we have two long stripes like this, on which one have pulses on them and other is regular. So when you're generally pushing those two cars down, we are observing which car first reaches the ground first. So here we observe that the car which is on the track with pulses over it will move slowly. Now, because we have more friction along that track, the frictional force resists the relative motion between the two layers, surfaces of materials. And in this example, currently we have the surface of tire on the car and that stripe of cardboard. So, due to more friction, it will resist the movement of tire along the stripe, and thus the car moves slowly. This car moves slow on the track with pulses on it. Now, here the frictional force refers to the force generated by two surfaces in contact and slide against each other, like I just tell you earlier. So this is a some surface, and this is another surface. This is a pushing force, let's say, and this is the motion, but the frictional force always act opposite. Okay, so here we are having a pushing force, but friction is in the opposite direction, because it resists the movement of that object on that surface. So here are some application of frictional force in real life. So matchsticks are ignited, then motion of pistons in a cylinder. You might have studied engine, so it is in there basically. So it is possible to write on books and board. Exactly. If friction was not there, those chalk pieces would not be there in board on the board, because if there was no friction, then nothing can be possible. The car moves our road, we can walk. And some other common example, if we can say, like, you just have an let's say an inclined surface like this, and just place a square or rectangle, whichever a box you have at your home. So, and let us assume that this is a movable surface, like we can increase or decrease its inclination. So it is a great example. Now we are placing a box, for example, at the center, and now if it is at zero inclination, the box will obviously not move. But when we start to increase it, it will slightly start to move at an point, but it will not move all the way. But at some point, let's say at a 30-degree angle, that box start to move down. So that is the point where the frictional force lag to oppose the motion force, or we can say the pull of gravity at this angle is stronger than the frictional force. That's why the object will not stay at the place where it was. So it is another good example, or you can do that experiment at home. Now think time. What if we had the two toy cars, uh, it's a mistake, I guess, at top two shoes, two shoe boxes, and does the angle that the cardboard sheet makes with the ground has a role to play? I just discussed with you. Just remember what I told you right now, a great example. So here's the answer. Yes, it will increase the speed at which the toy car will move down. More angle with ground, respect more more angle with ground, directly proportional to the speed. So as the angle will increase, the speed of the object, or in this particular case we can say car, it will increase. As the friction decreases, in the example previous, here it was a maximum friction at zero inclination, but at 30-degree inclination it start to move, the object will start to move. And as we just increase the angle, the act of the force, gravitational force will increase, and the frictional force, or the what we can say, the impact of frictional force will decrease, and impact of gravitational force will increase. And that's why the speed will naturally increase by increasing the angle. And that's why the angle of inclination is directly proportional to the speed of object that is moving on that. So let us see what we have studied today from starting. Okay, so we have first the force. What is a force? It is a push or pull upon an object resulting the interaction with other objects. So it is nothing but the force. And we just know that force is a vector quantity. Then we have seen the examples of force and generating heat due to frictional force, and what is the phenomenon behind that, or what is the technique behind that. So kinetic energy is converted into thermal energy, that's why we feel heat. And then we had an experiment on which we saw that how pulses on in our particular case, we can say, impacts the frictional force. Then observation was that the car moving on the pulses will move slowly because of more friction. And here we had example regarding this, and here the real life application which we saw, that matchsticks are ignited, motion of piston in cylinder, or car moves on road, we can walk. So those are the real life applications. And then, would inclination matter, or how much inclination would be required for it, the object placed above it, to move? So, and the more inclination will affect the speed. And yes, answer is yes. More inclination will means more speed. So that's all for today's session. If you have any other questions, you can just put in the comment box, and I will try to answer them. Thank you.